Hi, in this video we will look at an example of power transmission coupled with shear stress due to torsion. So it's really good problem to connect both topics together. So this is a shaft. It's a hollow shaft. So it has outer diameter and inner diameter. And the shaft transmits 123 horsepower at 3,800 RPM. So they give us a few things. They give us the power. It's in unit of horsepower. And they also give us the angular velocity in the unit of RPM. Okay. So remember the power transmission. We're talking about power is equal to torque times omega. But we're talking about often in US, the power is used horsepower and omega is using RPM. And then we can figure out the torque that will be in unit of pound-foot. If we do that, and we already figure out this magic number 5252. So you don't need to convert every single time, you just use it. And so torque is equal to this power. We're gonna use horsepower and divided by omega. Omega, we're gonna use RPM. So here we can quickly figure out the answer. So 52 times 5252, horsepower for mine is 123, and then divided by 3,800 RPM. That's all. And then you are guaranteed to get the unit of pound-foot for the torque. Okay? And I can actually maybe put it in there. 5252 times 123 divided by 3,800. And I have about 170. Okay? That's going to be my torque applied onto this shaft. And they also said the torque of the shaft cannot have a shear stress more than 11 KSI. KSI means what? Kips per square inch. So it's basically 1,000 PSI. Then we have to relate our next topic, which is shear. Shear stress tau. Tau is equal to the torque times the maximum shear, right? It's going to be T. And this is going to be using the radius. TR over J. Because we normally use tau is equal to TC over J. And the C is the range from 0 to the outer edge, which is going to be radius. So here we know the outer edge going to have the maximum value, and this maximum value cannot be higher than 11 KSI. So we're going to equate that to be 11 KSI. And we just figured out the torque from power transmission is 170 pound-foot. And this radius, now let's look at the cross section. Cross section is a hollow one, right? And we know at this outer edge here, you're going to have a maximum shear, and that's going to be our radius. And for this problem, the radius happened to be half of my B, because B is the diameter. So mine will be 1.25 divided by 2. That's going to be the radius. Then how about J? J is polar moment of inertia for this hollow shape. We know it's going to be half this outer diameter, 1.25 divided by 2, power 4. Oh, it's pi over 2. Then minus this inner radius. This inner radius will be, if this thickness is A, we have to figure out what's going to be this radius in this orange color, right? Now, the outer radius is B over 2. And then, if this is B over 2, then we're going to minus this thickness A. Then what we got is right here. That's going to be the inner circle radius. So that's going to be radius of inner circle. That will be our 1.25 0.25 minus 2, because B is that value, minus A, that's 4th power. Together, that gives us the expression for J. All of that should give us a value of 11 KSI. Here I would encourage you to look at the unit, because likely the unit might need to be fixed. Let's think about it. So here it's in torque pound-foot, and here is radius, that's in inch. And all those here bottom for J, that's going to give a unit of inch to the power 4. Obviously, if you look at all those units, that will not give us to KSI. So first we need to convert this foot to second. So we're going to add 1 foot is going to be 12 inch. That's the first thing we did. And then on the top, we will get foot canceled out, so we'll get pound foot inch square. And the bottom is inch cube. The inch square canceled out, and then we get inch square, so we get PSI. So in order to make this equation work, we have to make this to be PSI. So we're going to times 1,000, because 1 KSI is going to be 1,000 PSI. So that canceled out. Then we both sides will get the unit of PSI. Then that would work in terms of numbers. Then the rest is calculation. And I have to say this will be messy calculation. But at the end, you will get something. If you know this is a constant, this is a constant, this will be a constant. So if I'm gonna simplify, you will get some kind of coefficient. Here I'm just give you a random number. 2 times, for example, 0.625 minus A to the 4th. That gonna give you a value equals some kind of constant. Make it 3. Well, so then essentially you will be able to just get, for example, this is gonna be just equal to 1.5. Okay, I'm making most simplistic assumption. So when you make that, and then you can again put into Wolfram. We talk about in one of the videos. Put into that software online platform. Then you can solve your A. Okay, or you can just figure it out. You know, you can solve that maybe also. But no matter what, then you can find your A. Okay, for my value A, if you are curious, I actually have a value for A. Let me see. So you can verify it. My value for A is 0. Oops, you went too fast. 0.095. 0.095186, something like that, in inches. Okay, so that's for this problem. It's a good problem, other than the last step calculation might be messy, but it's coupled with power transmission with shear stress. And this is the example with a hollow tube, and we look at how we calculate the moment of inertia. And that's it for this problem. I'll see you at the next one. Bye.